Okay, welcome back, and today we're going to do the final test, chi-squared test, and it's going to be the final topic for this chapter on the chi-squared distribution and chi-squared tests in general. So this is going to be what we call the test for homogeneity, and like I said in the last video, it's very similar, or it's not similar, it's a special type of independence test. In fact, it uses the exact same methods, steps and methods that we did for the test for independence. Same thing. The only difference is the null and alternative hypotheses. So the null and alternative hypotheses are going to be about the distribution, about proportions. So we're going to be comparing populations. And so let me just show you something. And it could be for two populations or more. So the hypotheses would be the distributions of the two populations are the same, or the distributions of the two populations are not the same. So remember what I talked about independence, about if the two variables are independent, then we would expect the distributions to be the same. Then, well, that's kind of like what we're doing for homogeneity, is we're testing to see, are the distributions between two populations the same? So in independence, we're talking about distributions within the same population. So the distribution of variables across another variable within one population. Here in homogeneity, we're testing to see whether the distribution of the same variable is the same between two different populations. So for example, we could compare the distribution of gender for two different populations. We could talk about the distribution of ethnic background across two different populations. See if the distribution of ethnic background is the same between two populations, or three populations. Okay, so that's what we're looking at. Okay, so the hypotheses are going to be based on that. And so everything we're going to do is the same because, again, it's a special type of independence test. Okay, so let's do an example of where this would come across. Okay, so let me do this. Okay, so here are some common uses. We can compare two populations. For example, men versus women, before versus after, east versus west, and so on. So here's the example. It says, it is claimed that male and female college students have the same distribution of living arrangements. Okay, so here we want to compare two populations, right? Men versus women, okay? So, and they're claiming that they have the same distribution of living arrangements. So here are the different living arrangements that are possible, that we're considering. Dormitory, apartment, with parents, or other. Okay, so those are the four. And what we're saying is that it doesn't matter whether you're a male or female, the distribution is the same. Okay? So, what we're going to do is we're going to test that. So, suppose that 250 randomly selected male college students and 300 randomly selected female college students were asked about their living arrangements. The results are shown in the following table. So again, there's the table. Okay, if you want to write those down. Okay, so now, do male and female college students have the same distribution of living arrangements? Use a level of significance of 0.05. So now, the null hypothesis is that the distribution of living arrangements for male college students is the same as the distribution of living arrangements for female college students. So what I'm going to do is I'm going to say that P for female, so the distribution of females is the same as males. Okay? Yeah, do I want to say it that way? Yeah, let's do it that way. Let's just write it this way. So the distribution of living arrangements for male college students is the same as the distribution of living arrangements for female college students. That's a lot to write down. That is the null hypothesis. The alternative hypothesis is that they are not the same. So they are not the same. Okay, I'm not going to write out the whole thing. Okay, so now, in this case, again, the degrees of freedom are going to be 3 because there's 2 rows and 4 columns, so it's going to be 1 times 3, which is 3. Okay, so remember, it's number of rows minus 1 times the number of columns minus 1. So now, that's step 1. Step 2 is going to be what? Assume they're the same. So assume the null is true. Okay. So we're going to assume that the distribution of living arrangements is the same for both male college students and female college students. And so step 3, we're going to, again, what's our alpha level? They don't give us an alpha level. No, yes they do, 0.05. And the degrees of freedom, of course, we just talked about, is 3. Now, the table, so I'm going to write out the table since it's not that big. And we got, so we've got the male and female. And so we've got the dormitory, apartment, with parents, other. And so we've got 72, 84, 49, 45, 91, 86, 88, and 35. And so what we're going to do is we're going to take this and put it into our matrix A. And then in step 4, we're just going to use the same thing that we did before, independence chi-squared test. And we're going to put in our matrix A, and then that's all we need to put in because the calculator will create our matrix B, which again is our expected values. So we're going to put in our observed values and then put it in our calculator, and then we'll get what we need. So let me do that. So I'm going to put mine in the calculator. I encourage you to do the same thing. Okay, now I entered my matrix. Now I'm going to go to my stat test. And now I'm going to go down to calc. And 10.13. So I got 10.13 My p-value is 0.0175. And so now 5 is, what am I going to do? I'm going to, oops, sorry. The 5 is my comparison. So p-value is equal to 0.0175. That is definitely less than alpha, which is equal to 0.05, right? From here. And then 6 is my result, so therefore we reject the null. And so again, at an alpha level of 0.05, and based on the sample data, there is strong evidence to reject the claim that the living arrangements, or excuse me, the distribution of living arrangements for male and female students at this college are the same. And that's it. That's the test for homogeneity. So again, all we're doing is we're testing to see if the distribution for two different populations are the same. So in this case, we're talking about the distribution of living arrangements for the population of male students and the population of female students at the college. And you can see how this is also an independence test, because a way of looking at it, you could look at it as you're looking at the independence between gender and living arrangements. That's really what you could look at this. You could rewrite this as, is there a significant relationship between gender and living arrangements? Right? Based on what we talked about last time. And so yes. So it is just a special way of doing independence. Okay, just a different hypothesis test. Okay, let's see here. Let's do one more. So the next example says, do families and singles have the same distribution of cars? Do families and singles have the same distribution of cars? So now we're going to look at two different populations, the population of families and the population of single people. And do they have the same distribution of cars? Okay? And here are the different types of cars that we're looking at. Sport cars, sedan, hatchback, truck, and then van/SUV. So vans and SUVs are grouped together. So it says use level significance 0.05. Suppose that 100 randomly selected families and 200 randomly selected singles were asked what type of car they drove. The results are in the table below. Do families and singles have the same distribution of cars? Test at a level of significance of 0.05. Okay, so there's the data. Okay. So go ahead and pause and copy that down. So enter that in your calculator. So here's what I'm going to do. I'm going to go ahead and enter all this data into the matrix before I even do the test. So go ahead and do the same thing. I'm just going to quit out of this. I'm going to create my matrix because I know I'm going to use it. So I'm going to go to second. Okay. And so this is a 2x5 matrix. Okay, I got my matrix created, and so now let's do it. So here is the null and alternative hypothesis. So the null and alternative hypotheses is that the distribution of cars, so we're going to say the distribution of cars for families and singles are the same versus the distribution of cars for families and singles are different. Okay? Now, again, we could look at this as the test of independence between make of car, type of car, and type of living situation, whatever you want to say. So, but again, this is easier to do, easier to think about, I guess. So anyway, so here's the test for homogeneity. Is the distribution of cars the same between these two population of families, population of singles? So now 2 is we're going to assume that they are the same. So assume the null is true. 3, here's where we're going to put down our alpha level, which is 0.05. And just so we know, what is the degrees of freedom? Well, in this case, we have 2 rows, 5 columns. So it's going to be 1 times 4, so it's going to be 4. So now the table, again, I'm not going to write down the table, I showed it to you, but we have the table of values, and that's going to be our observed values. Okay? So the table is the observed values, and that's going to go into our A matrix. Okay? And then step 4 is just going to chi-squared test and putting in our A matrix, right? In fact, it's already going to be defaulted, so actually you could just go down to calculate because it assumes A and B. So as long as you put your matrix in A all the time, you just go down to calculate. So I'm going to go to stat tests, chi-squared, calculate, and now my chi-squared test statistic is 62.91. My p-value equals another small number, 7.08 times 10 to the negative 13. So again, essentially 0. So again, the result of our test, or our comparison rather, is going to be p-value. Again, you could do the chi-squared, the traditional method, but p-value is a lot easier. So p-value is basically essentially 0, which is less than alpha equal to 0.05. And so again, we are going to reject the null. And then 7, our conclusion is what? Based on an alpha level of 0.05 and the sample data, there is significant evidence to reject the null. Strong evidence to reject the null. So in other words, the distributions of cars are not the same between families and singles. And that should make sense. That's it, guys. That is the last thing. That is the end of chapter 11. Or excuse me, yeah, chapter 11. Next time we're going to start chapter 12, and it's going to be all about a new topic called on correlations. We're going to talk about correlation, and we're going to talk about regression. And we'll see you next time.